Okay, great. Who has questions?
Hi, thanks for your talk. I was curious when you were showing the most extreme case, the faintest thing that you said was 16 solar masses, and I feel like, what? Um, yeah, so can you say more about pushing in that direction? Like what really it starts? I'm very, I don't know, I'm amazed by this and puzzled at the same time.
Sure, yeah. So the first thing I'll say is that the theorists do tell us that we should expect dwarf galaxies to at least 100 solar masses and stellar mass. Those are the galaxies we expect to inhabit sort of 10 to the 7 dark matter halos, and we're starting to have good reason to believe they really do exist. This particularly faint one was discovered by a survey in the northern sky called Unions, and it's a little unclear whether it's a galaxy or whether it could be sort of the stripped remnant of a galaxy or a star cluster. But in some sense, it doesn't matter because now we're going to have to check every single one of those systems to see whether they are galaxies. Because if there really are systems down there, we could get the luminosity function of Milky Way satellite galaxies very wrong. And so I think what this has shown us is, I'm not going to stand here and say this is the faintest galaxy we know of, but it's possible. And now we're going to need to check with Rubin whether these objects that are sort of floating at absolute magnitudes of 0 and fainter are really galaxies.
Yeah, next question.
So actually, two questions for you, Will. So very early in your talk, you showed that you can sort of express the expected number as a function of the timing of the epoch of reionization. So if we imagine that that's actually something we're just going to measure from like actually observing it at, redshift 5 to 15, what happens then? Where's the other wiggle room? Because that will basically give you some kind of prediction for those numbers. And if they don't match, what's the other knob to turn?
So I'm not sure I have a complete answer to your question, but what I can say is like it is one parameter in a large semiotic model, right? We're trying to make predictions for the population, and you can think of it in some sense as a parameter which you can constrain. Maybe you could use a prior if you had some other constraints, but it's one thing you could constrain along with these other things like the efficiency of gas cooling or the star formation efficiency, all these other things. And so I'm not sure that really answers your question. But it's one independent way of probing something we can observe sort of directly now in the high redshift universe.
I think saying it's a semi-analytic model is probably a sufficient explanation. My other question for you is at the second to last slide, you said a place where machine learning could contribute is sorting through on order of 10,000 detections without requiring human visual inspection. I'm not scared by looking at 10,000 pictures at all. So what actually would machine learning bring to that that we wouldn't get out of visual inspection? What would we imagine that going through that process would bring? Because that's not a large number of images to really examine.
Yeah, absolutely. So I think what we're really looking for in trying to move away from visual inspection is the reproducibility, right? So what we're trying to do is do, what we call precision near field cosmology, using satellite counts and some very good understanding of our selection function to make inferences about dark matter. And we really can't have a good, well-constrained selection function if it depends on how, efficient an individual human is at looking through detections and trying to pick them out, right? Because that could, in principle, have a large effect on what your overall completeness correction is for the total population of these systems, for example.
Okay, if there's one more quick question, we can do that while our next speaker gets set up.
Just a quick follow-up on the first question that was asked about the 16 solar mass population that you were talking about. And you just mentioned simulation works. It's totally possible for, to have 10 to the 7 solar mass, halo to be populating that. Can you maybe just say a little bit more, like what is the implication on, like, for example, stellar mass, halo mass relationships when it comes to that exact point, and like star formation efficiencies, people throw around like feedback being like not able to sustain that small of a population, etc.
I don't think I have a quick answer to your question, so I think I'll let the next speaker start and I'll follow up with you after, but
Yeah.
I'd be very happy to talk with you about that.
Thank you.
Okay, let's thank William again.